Hello everyone, welcome back to Turito's live classes. How are you all doing? I hope you all are doing great. So students, we have started with the one of the most fundamental concepts, that is nothing but chemical reaction and equations, right? We have seen differences between physical and chemical changes. Then we jumped on what is a chemical reaction is, right? Then now since last lecture onwards we have started something called as balancing a chemical reaction, okay, which is based on law of conservation of mass. So it's time to recap or revise whatever we have studied in the last class. So let's get started. So we have covered law of conservation of mass, like what is law of conservation of mass, right? Then based on this we try to balance some chemical reaction, okay. Those examples were quite easier, or I can say already balanced one. So in last class I tried to make you understand that what a balanced chemical reaction looks like, okay. If you all remember, like these were some examples which we have seen yet, right? Calcium carbonate giving you what we have seen this example. Just a minute, let me show. Yeah, here. So we know that when we say reaction needs to be, or it's supposed to be what, balanced, then we know that we are having two sides in a single chemical reaction. First is what, LHS. Here we are having reactants, and the other side we are having products, right? Now the total mass of the reactants need to be get matched with the total mass of products which we are having in the chemical reaction, and that is what is law of conservation mass, or here is expected that total number of atoms are supposed to be, they should be similar, they are supposed to be exactly same on the other side also, okay. So here if you will see, we are having calcium carbonate. So CaCO3, like calcium, carbon and oxygen. Let me quickly write it here. We are having calcium, right? Then carbon, then oxygen. Then what we need to do, that we just need to see how many number of atoms these different types of elements have on the both sides. So in the left side, calcium is 1. Here in RHS it's 1. Carbon 1. There also 1, oxygen 3, there CaO, that is O1, CO2, that is 2, that means 1 plus 2, 3 atoms are there, okay. If we'll see, calcium, number of calcium are balanced, number of carbon and oxygen also. So I can say this is nothing but a balanced chemical reaction. Okay, so let's quickly try to understand like how are we, these were some rules, right, which we have gone through. So let's, with the help of some example, try to understand like what a chemical reaction is, or what balancing of chemical reaction is. So try to understand that many times you will be provided with this word equation, okay. Sometimes they will ask you, or if zinc is reacting with hydrochloric acid, what is happening, maybe in a question format they can ask you, okay. Or sometimes they will give you a proper equation which is unbalanced, which we need to balance, okay. We are going to see some examples through which we will learn balancing of chemical reaction, okay. So zinc is reacting with sulfuric acid, giving you what, zinc sulfate, a salt, along with the release of hydrogen. So zinc plus H2SO4 giving you what, zinc sulfate ZnSO4 and release of hydrogen gas. Got it? So quickly, how many elements do you have? Zinc, then we are having hydrogen, then we are having sulfur, we are having oxygen, right? So quickly count the total number of atoms which we are provided with in this chemical reaction. Zinc 1, there, here it is 1, right? Hydrogen 2, there also 2, sulfur 1, there also sulfur 1, oxygen 4, O4, right? There also 4. So that's how this is nothing but a already balanced chemical reaction. So what I am trying to tell here that we need to balance any chemical reaction. According to law, the total number of atoms which are present on the left hand side or in the reactant sides are supposed to get equivalent, or they are supposed to be like there on the other side the number should get matched. Okay, here it is balanced, it is matched. So that's how I can say it's a balanced chemical reaction. Moving ahead, we are having hydrogen which is reacting with oxygen, giving you what? Water. This is a very common or a familiar example for us. Hydrogen, then we are having oxygen, a little small example of a unbalanced chemical equation. Here how many, this is your LHS, this is your right hand side, hydrogen 1, there also sorry hydrogen 2, there hydrogen 2, oxygen 2, here H2O O1. So we do not write 1, that we know, right? So 1. So hydrogen is balanced, but we need to balance now oxygen. Can I do something like this? Into 2 is going to give me 2. That's how it can get balanced to 2. That means I need to add stoichiometric coefficient. This is what we called as stoichiometric coefficient in front of a compound or product or reactant. Okay, so after, okay, I have explained you how are we supposed to calculate number of atoms when we are provided with a coefficient in front of a compound. So 2, like if I want to calculate hydrogen, it is 2 into 2, which is 4. For oxygen it is 2. Got it? So that's how oxygen is getting balanced 2 2. But in order to balance oxygen, we add coefficient 2 in front of H2O. But actually if you will see, we are having 4 hydrogen, and now we have disturbed the balancing of number of atoms. But we can balance by adding 2 in front of H2. Do you all agree with this? Now we are having what? 2 into 2, that means 4 atoms. Here also 2 into 2 giving you 4 hydrogen atoms. That's how this reaction becomes a balanced chemical reaction. Then we are having, okay, so this is what is another type of question they will be asking you, like zinc is reacting with hydrochloric acid, what it is going to give you. Now here you should know, this is nothing but reaction of metal with acids or reaction of acids with metal. We have studied about that. So you are going to get something called as zinc chloride, something looks like ZnCl2, right, along with the liberation of hydrogen gas. Got it? Quickly, Zn, then H, then Cl, right? This is your left hand side, this is right hand side. Number of atoms 1, there also 1. Hydrogen 1, hydrogen 2, correct? Then chlorine 1, here is chlorine, right? There chlorine 2. If we will see, we are having like balanced zinc atom, then hydrogen 1, and we are having hydrogen 2 there, correct? So in order to balance now, what we can do is, let's suppose if I am adding 2 in front of this. So this is giving you 2 hydrogen on which side? Left hand side. So 1 into 2 giving me 2 hydrogen. Now it is balanced, right? And if you will see on the other side, actually we have added this coefficient, right? So that's how now chlorine is also 2. Earlier it was only 1. Okay. So this is applicable for chlorine also. So there are 2 chlorine atoms on the LHS side. Now let's try to understand, like, okay, chlorine, 2 chlorine, hydrogen, 2 hydrogen. So 1 1 2 2 2 2, right? So that's how we can say this is also a balanced chemical reaction. Now you need to write it, like what is your final reaction? Zn 2HCl giving you ZnCl2, and there is liberation of hydrogen gas. Okay, clear? Just make a note of this thing quickly. This method is called as hit and trial method. If you will see, the name is written here, hit and trial method. We are going to think about the stoichiometric coefficient, where are we supposed to add, where are supposed to decrease or increase the numbers, okay. And we are going to just, where is a trial method, okay. So there are chances that you will get confused while solving it. So we will just have to calm ourselves and then do this calculation carefully. Okay, done? Shall we move ahead? Okay, so here it is the like a quite longer chemical reaction we are having. So try to understand what we are provided with. It's a magnesium nitride, okay. Then we are having water, both are reacting, giving you magnesium hydroxide along with NH3. Okay, that is what is the reaction. Now quickly enlist all the metals which we are having. We are having magnesium, we are having what? Nitrogen, then we are having oxygen and hydrogen. Just cross check, are we missing any element or any atom from the equation? No. Yeah. So here before balancing this chemical equation, I just want to tell you one thing, that it is my advice to you that whenever we are having any chemical reaction, this chemical reaction like most of the time it will have oxygen and hydrogen in it, okay. These are two non-metals, and you will be provided with some metals and other non-metals also, okay. That depends on reaction to reaction. Now there is this preference we need to give. First preference needs to give metals, then non-metals, okay. If I want to show, then you try to balance oxygen atoms, then hydrogen atoms, okay. This is what is advisable, kind of a trick you may consider it as, that always try to balance metals first, then followed by non-metals. Here we are having magnesium as a metal, then nitrogen is non-metal, and oxygen and hydrogen. That is what is the sequence, okay. So let's try to apply it here also. We are having magnesium, LHS side, then we need to understand how many atoms are there on right hand side. Magnesium 3, okay, magnesium 1, nitrogen N2, nitrogen 1, oxygen, here it is 1, right. So 1, it is applicable. Remember I told you, if this is the case, how are we supposed to calculate number of atoms? So it is O2, okay, it is hydrogen 2. This is applicable for both the atoms or the elements, okay. So here oxygen 1, there oxygen 2, hydrogen 2, correct. Here 2 hydrogen here and 3, that means how many? 5, right. 3 from NH3. Just cross check it, like magnesium 3, magnesium 1, nitrogen 2, nitrogen 1, oxygen 1, oxygen 2, hydrogen 2, and 2 plus 3, okay. So what we are going to do, we are going to balance magnesium first. What if I multiply this with 3 is going to give me 3 magnesium? Do you think so? Yeah, of course. So write 3 here, 3 mg, okay. So 3 and 3, magnesium is balanced. Now let's come towards the next thing, okay. So nitrogen 2, there only 1 nitrogen is there, okay. So now what do you think, shall we add 2 there? But if you'll notice, when we add 3 in front of MgOH twice, actually this 3 is applicable for your oxygen also, then it is applicable for your hydrogen also. Then that time we will have to be very careful while calculating number of atoms which we are having, okay. So try, let's multiply it with 2, giving you 2 nitrogen, write 2 here, okay. Now if we'll see, let's like magnesium and nitrogen are balanced. Now coming towards oxygen. So be careful while calculating. It's 1 already there, right? Now here there will be change. It won't be 2. How? Because see, we have added coefficient 3, and now 3 is applicable for 2 also, oxygen also, and this 2 is applicable for oxygen, right? So 3 into 2, how many oxygen? 6, right? So I'll cut this out. 6 oxygen from hydroxide. There, how many, 6 oxygen from hydroxide. Okay, so that is how something different had happened here. Okay, are you all able to follow it? Okay, so now let's move ahead and try to understand. If there are 6 atoms, okay, of oxygen, I think we need to multiply here by 6. Okay, so if I am writing 6 here, so it's giving me 6 oxygen, correct? Now we are left with, like, this is what? 6, this is 6, oxygen is balanced. Now focus on hydrogen. We have made many changes. Now we just need to, you know, balance hydrogen now. But before that, just calculate the number of hydrogen. 6 into 2, it's 12, right? There try to balance it. Look at 3, like 3 into 2, that is what? 6. And here also 2 into 3, 6. That means 12 hydrogen. See, I'll repeat. 3 is applicable for hydrogen. 2 is applicable for hydrogen. And I have told you, if this is the case which we are provided with, then we simply multiply. So 3 into 2, 6 hydrogen from this group. That's why I have written 6 here. Okay. Moving ahead, we are having NH3 which has a hydrogen in it, right? And we have added coefficient 2. When did we add? In order to balance nitrogen atoms. That time we added 2 in front of NH3. That actually changed number of hydrogen, and like 2 into 3, 6, giving you 12 atoms of hydrogen on the other side. Okay. So 12, 12, 6, 6, 2, 2, 3, 3. Now this reaction is nothing but a balanced chemical reaction. Quickly make a note of this. Done? Let's move ahead. Okay, this is a word equation. We are having sodium which is reacting with water, giving you sodium hydroxide with the release of hydrogen. So let me write it here. Na reacting with H2O, giving you NaOH, sodium hydroxide. And there is liberation of hydrogen. Okay. This is what is our chemical reaction. Now quickly, we are having what? Sodium, then we are having oxygen, then hydrogen. Remember the preference metals, non-metal, oxygen, hydrogen. Okay, so we are having, metal as sodium. Okay, so quickly, one metal, there is one sodium, oxygen, one oxygen, oxygen here is 1, hydrogen, 2 hydrogen. Here we are having hydrogen, 1 from hydroxide group, and there are 2 hydrogen in H2, right? Hydrogen atoms, 1 plus 2. That means 3 hydrogen are there, and which it is imbalanced in case of hydrogen atoms only, because sodium and oxygen are balanced. What can get done? Okay, we will have to change, like we will have to add, you know, suitable or appropriate coefficient so that the whole equation will get matched or, you know, balanced. Suppose we know that if there is nothing, actually there is coefficient 1 is there, but it is not balancing the chemical reaction. So what if I am going to add 2 as a coefficient in front of H2O? What will be the change? So it is not going to remain 2, it will be 4 hydrogen atoms. Just calculate this, 2 into 2, 4, right? So while doing this, actually if we will see, we have changed the oxygen number also. So earlier it was 2, now it is, earlier it was 1, now it is 2. Okay, so actually now we have to balance hydrogen and oxygen both. Now how are we supposed to do that? Let's see. Okay, what if I am adding 2 here? Because it has oxygen and hydrogen also, right? So in order to balance oxygen, I added 2. Now oxygen is balanced. Just check. Are you able to understand like what I am doing here? I have just added 2 as a coefficient in front of sodium hydroxide, which is giving me 2 atoms of oxygen. That's how oxygen is balanced. But if we'll see, this 2 is applicable for hydrogen also. That means there are 2 hydrogens and 2 hydrogen from hydrogen gas. 2 plus 2, 4. So it's not 3 now. It is 2 plus 2, 4. Got it? 2 from sodium hydroxide group and 2 which are there in the hydrogen gas. Okay. Why? Because we have added coefficient as 2 here. Okay, so hydrogen oxygen is balanced, but what do you guys think? We have added 2 in front of Na also. So that means we are having 2 atoms of sodium on the product side. Can we not add 2 here? We can, right? So into 2, 2 sodium atoms on the reactant side. So 2 Na plus 2 H2O giving you 2 NaOH and a release of hydrogen gas. Just cross check it quickly. Sodium 2, hydrogen 4 and oxygen 2. Okay, it's balanced. So this is what is your balanced chemical reaction is. Or you can write it after balancing the reaction. Okay, in the end you can write your balanced chemical reaction. Okay, shall we move ahead? Have you all copied down? Okay. Yeah. So this is what is our next example. That is what propane is reacting with oxygen, giving you carbon dioxide along with water molecule. Propane, okay, it's nothing but hydrocarbon, okay, and it has the chemical formula C3H8. Okay, this is what is a propane. When it reacts with oxygen, is going to give you carbon dioxide and H2O. That is water will be there. This is what is our chemical reaction is. So always try to understand when we are having word equation, you just have to write the molecular formula of each and every compound which is there in the chemical reaction. Next task is that write the total like how many different elements are there, because we need to count total number of atoms on the both the sides. Okay, carbon, there are 3 carbon, here only 1 carbon is there. Oxygen, 2 oxygen atoms are there, 2 from CO2 and 1 from water, right? 3 oxygen. Hydrogen, 8 hydrogen are there, whereas here we are having only 2 atoms of hydrogen. Okay, so remember the sequence. Is there any metal in the reaction? No. So we are going to balance the next sequence, that is non-metal. Who is that? Carbon. So if I am going to multiply, that means I will be adding coefficient 3. I will be adding coefficient 3 in front of CO2, which is giving me 3 carbon on the reactant product side. Now carbon is balanced, right? Moving ahead, we are having oxygen 2 and 3. See, we have added 3 in front of CO2. Actually now we are having 3 into 2, 6 oxygen plus 1 is there. That means what? 7 oxygen, correct? Yeah. So now what we can do is like if we'll see, if I am adding 4 as a coefficient, okay, 4 as a coefficient for H2O, and if I'll check the total number of hydrogen, like how many hydrogen do I have here after doing this, like 2 into 4, right? So that is giving me 8 hydrogen. So what I did, I just hold balancing oxygen atoms, I just jumped on H2 like hydrogen, I added 4 because I figured out, okay, if I am adding 4 here, I will be getting what, 8 hydrogen atoms. Now there is a change in number of oxygen atoms because this 4 is applicable for oxygen also. Earlier it was 1, now you have added 4, that means we are having 4 oxygen atoms. That's how it becomes 6 plus 4, which is 10. So in the product sides, we are having 10 oxygen atoms. 3 into 2, 6, 4 into 1, 4, that means 10 atoms of oxygen. But this is not the case here. Simply what we can do, I can add coefficient 5. 5 into 2, 10, right? So that's it. Carbon 3, oxygen 10, hydrogen 8. So this is my balanced chemical equation or reaction. C3H8 plus 5O2 giving you 3CO2 plus 4H2O. Okay, this becomes your balanced chemical reaction. Are you all able to understand this? Like, how are we going to do that? You know, when you will get used with this, you don't even require this part. In the reaction itself, you can easily change the coefficient and try to balance any given chemical reaction. I am making you all to write this thing because you will get familiar with the idea to balance any chemical reaction. Okay, that's how this is happening in detail. Initially, just to get familiar with this. Okay, done? Is there any doubt? Is there any confusion? Moving ahead. See, I was talking about the sentences. It can be a word equation or it can be a equation in the form of sentences. So they have given us steam is passed over heated iron to form magnetic oxide of iron. Now here we need to understand, like if we are having a steam has what? Water, H2O as a like chemical formula of steam is same, H2O. Now it is passed over what? Heated iron, that means iron is there. Fe plus H2O going to give you oxide, Fe3O4. Fe3O4 is the oxide, ferric oxide we are getting along with the release of hydrogen gas. Okay. This becomes your chemical equation which we need to balance now. Let's start doing it quickly. Fe, then we are having oxygen, then hydrogen. Okay, so 1 here, 3 are here, oxygen, only 1, oxygen 4, hydrogen 2, here 8. Okay, got it? So first thing first, try to balance iron. So into 3 going to give me 3. I'll be adding 3. So Fe is balanced now. Moving ahead. Now if I want to balance what? Oxygen, what I will have to do? Just multiply it with 4. If I am adding coefficient 4, this is giving me 4 atoms of oxygen on the LHS side, which is equal to the atoms of oxygen which are there on the right hand side, right? Coming towards this, see, we have added coefficient 4. Actually this had help us to balance hydrogen. So how many hydrogen are there? 8, right? And which is again exactly same in this reaction, 3 3 4 4 8 8. Got it? So this is your final balanced chemical equation, 3Fe plus 4H2O giving you Fe3O4 along with 4H2. Okay. Point number second, after sentence which they have given, they also have given 4H2. Okay, like a 4 is the coefficient which they have given in the equation itself. So always try to remember that you are getting this type of questions in your exams. Maybe they will be like they will giving you partially balanced chemical equation. They will give you, okay, or now you will have to do the balancing for the rest part or for the rest equation. Got it? quickly make a note of this. Okay, so this is nothing but like it looks very big, right, in the picture. So FeCl3 is reacting with NH4OH, giving you FeOH thrice along with the formation of NH4Cl. Now quickly Fe, then we are having Cl, then we are having nitrogen, oxygen and hydrogen, correct? So quickly count all the atoms on both the sides. Fe1 there, Fe1, chlorine 3, there number of chlorine 3 is applicable for this chlorine also, that's how 3, nitrogen 3, there also nitrogen 3, oxygen, how many oxygens are there? 3 is applicable for this oxygen. So here on the LHS side, number of oxygen 3, there this 3 is applicable for oxygen, which is 3. Okay, here we go for hydrogen. So this 3 is applicable for hydrogen, right? 3 like this 4, 3 into 4 gets multiplied 12, and this 3 is applicable for this hydrogen, right? 12 plus 3 15. So I'll write it for you. I'll explain it again. 3NH4, we are provided with 3NH4. So 3 into 4, 12. 3 is applicable for the next hydrogen also, which tells us that okay, there is presence of 3 hydrogen atoms. That's why I written 3, which is giving me 15. Total number will be 15 atoms of hydrogen. Moving ahead, on the other side, this like it becomes 3 OH thrice. Okay, this 3 is applicable for hydrogen, which is 3 in number. Then this 3 into 4, like this only, 3 into 4, oh sorry, 3 into 4, that giving you 12, we need to add this 3 plus 12 giving you 15 atoms of hydrogen. If we see, it is the balanced chemical reaction. Okay, so many times, or sometimes they will give you, though the reaction will look very longer, but it is quite easier. So here we are having balanced chemical reaction. Okay, but my motto behind this was you should know how to calculate total number of atoms when we are having this kind of cases, OH thrice or 3NH4Cl. We need to multiply it and then add it. Okay, quickly make a note of this also, it's very important. Okay, done? Yeah, this looks very small, right? S8 is reacting with F2 giving you SF6. Okay, quickly let me write S, F, then LHS side, there we need to RHS also. So how many atoms? Sulfur 8, there only one sulfur. Fluorine 2, here we are having 6. Okay, both of them are not balanced, so we'll be starting from sulfur. So what can get done? Into 8, right? Adding coefficient as 8. Got it? So that becomes your 8S. So now sulfur is balanced. But if we'll see 8 into 6, 48, right? So now here also we will have to multiply and get the total number of atoms of fluorine which is present on the right hand side. How did we get that? We added coefficient 8. Why did we add coefficient 8? In order to balance sulfur. Okay, now like there are 8 atoms on the LHS side. That's how I added 8 as a coefficient on the product side. Okay, so now what we can do? Now it becomes very simple, right? We can add 24. 24 into 2 gives you 48, right? 24 into 2 giving you 48 numbers of fluorine atoms. Easier one, right? So now both are balanced. This is what your, I'll write it here, S8, then we are having 24 F2, which is giving you 8 S F6, which is your final balanced chemical reaction. Okay. Next. Okay. So this is a sentence, that is combustion of methane gas gives carbon dioxide and water. So I should know how methane looks like. It is CH4 along with see, its combustion happens in the presence of your oxygen gas. So try to remember that also. That means O2 going to give you what? They have given the products, okay. So on combustion usually you get carbon dioxide and water, okay. Quickly now, C, then O, H, okay. C, okay. Now carbon, here it is 1, there it is 1, okay. Moving ahead, oxygen, 2 atoms of oxygen, there is 2 plus 1 giving you 3 atoms of oxygen, correct. Hydrogen, how many? 4 are here, there is only 2, okay. So carbon is balanced. Now what we can do, what if I'll add here as a 2 as a coefficient, if I'm if I want to balance hydrogen, so that is what I am getting, 2 into 2, 4 hydrogen atoms. But adding this coefficient is changing total number of oxygen which are there on the other side. So how many are there now? O2, and because of this now it is, if I'll write it again, okay, here I hope you all are able to see it clearly. This was first like we wrote it for the first time. Now second, after adding the coefficient, what is the change in the total number of oxygen, we will be writing it. 2 from CO2 plus 2 from like this, 2 is applicable for oxygen, right. 2 plus 2 giving you 4, correct. So which is again asking you to make the balance between oxygen atoms which are present on the both sides. Now let's see what we need to do. Into 2, that is how going to give you 4, which is nothing but addition of this coefficient. 2 into 2, 4, there 2 into 2, 2 plus 2, 4, okay. Oxygen is balanced, check with carbon is balanced, hydrogen H4, 2 into 2, okay, 4, it's done, it's balanced one. So how are you going to write it? Your answer should be CH4 plus 2O2 giving you CO2 plus 2H2O, okay. This is what your balanced reaction is. Quickly write it down. So this is different type of example I have kept for you all. Here only equation, word or sentences were provided, okay. Then you will have to write the equation with their chemical formulas, okay. Moving ahead, we are having benzene, okay. It's nothing but hydrocarbon or something C6H6, okay. So carbon, number of carbon will be 6, hydrogen will be 6. Again it is reacting with oxygen giving you carbon dioxide along with water. This is what is our equation looks like now. Now quickly note down all the elements: carbon, oxygen, hydrogen, carbon, oxygen, hydrogen. Yes. Is there anyone who is saying, ma'am, there is presence of metal here? Are you all able to see, is there any metal? No, right? So we are going to balance carbon first, okay. Let's see how we are going to do that. Count the total number of carbon atoms on both the sides. 6, 1, then oxygen 2. Here see, careful, 2 plus 1 giving you 3, 2 plus 1, okay. Then hydrogen, it's 6, there it's 2. O2, 2 plus 2, okay. So, if I am adding coefficient 6 here, that means number of carbon are getting balanced, right? Then moving ahead, after doing so, what we need to do? We need to balance the next thing, that is oxygen, 2 and 3. Okay. Okay, hold, like if I am going to add something like this, 2 into 3, if I am adding 3 here as a coefficient, which is going to give me 6 hydrogen. So, hydrogen is balanced as of now, right? But after adding this coefficient, we need to see the change, change in the total number of oxygen. So, oxygen is now changed on the right hand side. 6 into 2 is 12. 6 is the coefficient, 6 into 2, 12, which is coming from carbon dioxide. Here 3 is applicable for oxygen, 1, 3 into 1, 3, giving you 15 oxygen atoms. 15 oxygen atoms, okay. Now, what should get done? What do you think? Okay. So, now here is the trick. See, we are going to do, like we are going to multiply whole equation with 2, okay. That means what, 2 into 1, okay. That is nothing but 2C6H6, okay. Now, here is the trick. We are going to write something like this, okay. 15 into 2, divide and multiply by 2, which is going to get cancelled, which is giving me 15, right? Oh, sorry, 15, and now we are going to multiply it with 2, which is going to give me what? Okay, let me write it here, okay. So, plus 15 divided by and multiply by 2, giving you O2. Again 6 into 2, we are having what? 12 CO2. 3 into 2 giving you 6 H2O, okay, 6 H2O. Now, here try to understand, we are having now 12 into 2, that means 24 oxygen, plus 6 into 1, that is what, your 6 oxygen. We are having 30 oxygen altogether, okay. So, let us cut this, that is going to give you 15 O2, 15 O2, that means 30 oxygen. So, 2 C6H6 plus 15 O2 is giving you 12 CO2 plus 6 H2O. That becomes your final balanced chemical equation. That is why I said hit and trial method is there, okay. So, we can do these changes as per our convenient in order to balance the chemical reaction, okay. So, here 12 carbon, then we are having what, 12 hydrogen, 15 30 oxygen, okay. So, this is what I would like this as my final equation, C6H6 plus 15 O2 giving me 12 CO2 and 6 H2O. That is my final balanced chemical equation for benzene when it is reacting with oxygen. Okay, just cross check it. We just multiplied the rest part in order to get a proper number of oxygen with 2 basically, and then we divide and multiply by 2, then it becomes like we can cut it off. That is how we get 15 O2, which is 13 number, in order to get balance with the 30 number which we got there on the right hand side. Okay. Done? Yeah. That's all students. Actually these were some examples I kept for you all so that you all will get familiar with the balancing of chemical reaction, okay, with the help of fit and trial method. So I'll just summarize whatever we have learned. We have learned about law of conservation of mass. We have seen many chemical changes which are happening in our surroundings, okay. So it's not very convenient to write each and every chemical change with the name of all the chemicals. That's why we are having chemical equation, where we are having chemical formulas or any symbols like of any particular atom. They are interacting with each other, they are reacting with each other, and that's how we are having chemical equation, right? And now next comes like balancing of chemical reaction. According to law of conservation of mass, total mass of products has to be equal to total mass of reactants. In order to do that, we always need to balance chemical reaction. That means we are taking care of total number of atoms on the both the sides of any chemical equation or reaction. Okay, that was the idea behind balancing chemical reaction. Okay, I hope you all are able to understand till here. Okay, so yeah, that was all about. If I'm not wrong, we have learned more than, okay, in total 10 examples we have solved. Okay, so I'll give you some more examples in the next class maybe, so that you all can get practice, so that it will be helpful for you all. Okay, so that's it then. Till then, just keep studying. If you are having any doubt, do ask those doubts in next session. Till then, bye. Take care.